Afternoon, everyone, and thank you for joining us at today's Gas Industry Award webinar, which is organised by IGEM and EUA. Today's webinar will focus on the Engineer of the Year category and the two winners of the 2021 award, which are David Butler and David Ray. It'll be an informal chat today with the winners to discuss their careers, their influences, and the projects that they've recently been working on. What I would ask is if you do have any questions, please do post them in the chat and we'll pick them up as we go. As we move on to housekeeping, could I ask that you switch your video off and microphones, of course. It's just to save a bit of bandwidth. And again, the chat function within Teams is just to the side of your screen. You might see an icon on the side or an icon on the top right, where you'll be able to ask your questions. And we are recording the session today for your awareness, and we will make the recording available afterwards. So the category Engineer of the Year was awarded to those individuals who have made a very positive contribution to the safe, efficient and cost-effective running of a gas network. And the judges were looking for somebody that is committed to ensuring the continued safety of those working in the gas sector, its customers, and of course the general public. They're looking for someone that's a resourceful engineer, someone that embraces the use of new technology and materials and various ways of working in order to maximize the efficiency of a particular gas network. They're also looking for engineers and individuals that consider sustainability, so things like social, environmental, and economic impacts when they undertake any sort of engineering work. And of course, last but not least, they're also looking for evidence that the individual's efforts have improved business performance. So we've got David Butler with us today, and he is the director of SGN Natural Gas. And when nominated for the award, he was head of engineering and was recently promoted to director, I believe, in last October. The judges acknowledged David for his contribution to the safe, efficient and cost-effective delivery of Northern Ireland's newest gas distribution network. And I've been told that he's got a Bachelor of Engineering and a Master of Science in Engineering Computation and over 25 years experience in the industry working for both Phoenix Natural Gas and SGN Natural Gas. And of course, next to David, we've got David Ray, who is a project manager over at SGN. And David was recognised by the judges for his work as the principal engineer who was responsible and accountable for the project to replace the pipeline crossing the River Clyde in Scotland. So from initial planning to commissioning and completion within strict budget allowances under RIIO GD1, David overcame a number of technical and commercial issues in the execution of that particular project. And it's quite an intricate engineering feat. So David has a Bachelor of Engineering in Civil Engineering and 30 years experience in engineering, working for companies including Amet Utilities, National Grid Transco and SGN2. So we'll move on to some of the questions. And it's always an interesting one, given that this is an informal discussion, of course. Just to perhaps start with David Ray, it'd be interesting to know what actually inspired you to get into engineering, and then how has that sort of developed your career? How have you got to where you've got to today?
Well, ever since I was a kid, I've always been building things, and you know, I've got a young 5-year-old son, and watching him sitting playing with these cars took me back to when I was a kid in the back garden playing with cars, and I wasn't happy just playing with them. I always wanted to like build bridges for them, or build things. And my dad was always technically minded and stuff like that. So ever since I was a young kid, I knew I wanted to get involved in building things, and I chose civil engineering. You know, just for the fact of, you know, I wanted to do the big glamorous things and build these huge big projects that everyone could see. And I ended up, when I graduated back in 1991, right slap in the middle of a recession, there was very little work around, and I ended up in the gas industry kind of by mistake, really. I got a job with a company called Press Construction and started out in the water industry. And after about 8 months, they lost the contract that I was working on, and an opening came up in their special projects division, which was primarily doing oil and gas pipelines. So I was shunted sideways into that division, and from then on I've been in the kind of oil and gas world, and all these big grand projects that I've been building become buried under the ground and nobody ever sees them. And if you now build something that nobody's aware of, that's you done a good job. So things have gone quite the opposite of what I expected, but I'm really happy with the way they've turned out.
Good, thank you very much. And David Butler, would you like to give us a little bit of insight into your childhood inspiration and how you got to where you are today then?
I think to a certain extent I'm probably the opposite of David in that when it comes to I always interested in how things worked, but I could never put anything back together again. I'm very good at taking things apart, but less so at putting back in this reassembly. In school, I was primarily interested in sciences, so I'm lucky enough to like lots of different subjects, but mainly sciences. So I ended up doing chemical engineering, mainly because a cousin was a chemical engineer, and that sort of got me into it. So I got in and did my degree in Queen's in Belfast, and as part of that, I was very, very lucky that one of the professors was looking for a student to work on a research project with a new company, or basically was part of British Gas, looking to bring gas to Belfast to do a feasibility study. So I did my research project on that. I was lucky enough, it was on pressure control and monitoring of governors. So did a bit of work, did my research project on that, which got me the degree, and they offered a summer job to do the initial feasibility studies and involved in it. So I've been really lucky. I've been involved in 2 projects, 2 completely brand new, you could say almost greenfield sites, starting out a project from the very start. So one at the very bottom end, seeing how everything is put together and learning from other engineers, and then in the second project, bringing it on and trying to bring through a team to do the same thing.
Yeah, and I can see that you're both chartered engineers as well. So when did you become a chartered engineer? And I'll hand that to David Butler in the first instance. When did you become a chartered engineer, and how has that really helped you to grow as an engineer and demonstrate your competency?
I think so. I'm chartered for about 7 years, maybe 8 years now. You sort of lose track on the time of it, but where it's probably helped me the most is in the preparations for the interview and preparation and putting together the portfolio and everything. You sort of sometimes maybe don't have the confidence of how much experience you actually have, and once you start putting together your portfolio, it gives you a little bit more confidence. Once you go through the whole interview process where you're talking with people who are very knowledgeable across such a wide range, and then you suddenly realize you actually do know and have the competence in a bigger range than you thought. So from a personal point of view, it gave me more confidence in the sort of the spread that I had done. And I suppose one fortunate thing working in a company like Phoenix or now SGN Natural Gas, we're very small, so we don't get the luxury of specializing. So we have to be able to do a wide range of things and across the whole sphere of engineering. So from operations through to construction, design, planning. So everything comes under for an engineer. So it's a really good grounding across the board.
I can certainly relate to that. And David Ray, what's your experience of it?
It's similar to David's, probably chartered around the same time, probably about 8 years ago or something like that. And it was something that had always been on my kind of agenda for a while to try and become chartered, and just trying to find the time to do it. And then I made a decision over one winter when things were a little bit slower, and I said, right, I'm going to do it now. And like David, pulling together all your experience and your evidence, I suddenly realised that I wasn't the young guy anymore who was just in kind of and could get away with saying, "Oh, I'm just new to this, I don't know everything." Whereas I realised I'd been in the business for at that point over 20 years and had gained a wealth of experience, and it certainly boosts your confidence, like David said as well. And once you become chartered, then you get a bit more involved in iGEM. Now, I'm not as fully immersed in iGEM as a lot of other people are, due to the fact that, I mean, I use my young son as an excuse, but I'm not the only person who's got a young son that's in iGEM. But it just seems to be very difficult to find the time to invest more into iGEM. But then the interactions I have had with iGEM, the people I've met have been fantastic, and I've gained a lot of experience from them. Now, I'm currently on the SR28 panel looking at the trenchless crossings spec, and through that I've met some fantastic people, some great engineers from across the business, that if it wasn't for my chartership and my involvement with iGEM, I'd never have got to meet these people, and I've learned loads from them in the process. So that's the one big thing that I've taken from it.
Yeah, I can definitely relate to both of those sides of things. I remember doing my technical report and looking back over the years and putting it all together. And even in my mind, I was thinking, well, every day is a school day, isn't it? Mm-hmm. So you always think that you're on the back foot. But when you map it all out and you map that all over to the competency and the criteria, and you think, oh, blimey, that's yeah, there's a fountain of knowledge there. Yeah, there's looking at the projects that you've both been involved in. I'm certainly interested to hear more about how you may have leveraged some of those skills that you'd be required to demonstrate for chartership in the skills in the projects that you've been involved in. So I know that David Butler, you've been involved in the Gas to the West project. It'll be interesting to hear a little bit about some of the achievements and the challenges on that particular project, and perhaps how chartership helped you with that as well.
Yeah, so I suppose starting out on the project, the first thing is you're coming in from a very small company to what is a very large organization in SGN. So it's that whole culture shock of moving from one style of doing things to a larger style. So there's that challenge, and coupled with trying to recruit a team and then set up a business over here. So and extremely tight deadlines. So everything in this project has been under pressure time-wise. So it has been very enlightening that way. In terms of what we've had to do, it's building, trying to bring in ideas from the smaller company into the bigger company, particularly when some of the IT work and so on are a challenge, so it's trying to get everything around like that. Once we were building, also obviously as well, SGN maybe isn't as used to having a big C in between the two parts of the business. So simple things like getting mapping across and so on became more of a logistical problem for us. So we had to overcome all those sort of very basic things, but can get in the way. In terms of the project, from the distribution and the IP side, it was 140 odd kilometers of IP main to be constructed. The first part of it, we did 30 kilometers in the first year. I see James McStravo on the call here, who's lead engineer for Nicholas and now Kier. So they were our contractor on that project, and that was we laughed at it. We started construction on the first week in November in 2015, and it started raining that day. It would have been beautiful weather up to that point, lovely autumn, and it didn't stop raining till April. So the poor guys are out in that shocking weather for the full time. So it's really the challenges we had was trying to work in a very remote rural area with poor logistics anyway, and then shocking weather, and the project itself has been dogged pretty much with terrible weather. A lot of rain. We had beast from the east in the middle of it and various things like that. So that's been a real challenge that way. And then while doing that is then setting up a distribution company to bring the gas into the towns. So all the stakeholder that goes involved in that, meeting the councils, working with their PR company, setting up with the PR company and so on, and setting up all the back office systems then to try and bring learnings from my previous days in, and for things like preparing for price controls and preparing for cost reporting that goes with that.
That's it's pretty. I mean, it's pretty impressive. And do you know how many river crossings and water course? Can't speak today. The water course crossings that you did through the project? Because I imagine there's quite a few.
Oh, then definitely there are more than a few. On the two projects, sort of things that we would classify as proper crossings, where you're crossing either a substantial river or there was about 26 of those to be crossed, so quite a challenge. Most of them were through HDD around the side of structures. So I suppose to set the scene, the vast majority of this pipeline is laid in the carriageway. So it's laid in plastic, laid in the carriageway. That helped both with planning permission and with actual construction, getting access. Northern Ireland is a little bit different as well from GP in that a lot of the farm holdings are very, very small. So I know our colleagues on the high pressure had to, for 78 kilometres, had 600 landowners to deal with, to negotiate with at the start, and then whittle that down to 200. So that's an awful lot of logistics that need to be put in place. So we stayed in the carriageway. An awful lot of river crossings. The bridge infrastructure here isn't the best, so the opportunities there's no existing pipes over the bridges. There's no depth of cover on the decks of the bridges to get across. So most of our crossings were to the side of the bridges. So it was a real challenge. We have a couple of very interesting projects done, which is one of them was the crossing at Lough Erne. There's an island in the middle of the lake, so it's a drill shot onto the island, a drill shot back off the island. So two 400-meter drill shots. So.
My goodness. And yeah, I can see that. The one thing that's blowing my mind is how you built a team. How big is the team, and then how did you build it so quickly?
So the team is still very, very small. So we're very much contractor led. So for the IP part of the projects have been with contractors, and the distribution is all contractor led, which again is back to it's Keir doing that. In terms of engineers, I have 4 engineers, so 4 project engineers, and to be honest, we use the tried and trusted method. We poach them from other companies. So we've some from Phoenix, some from Firmus, and 1 across from SGN. So particularly pleased with getting those.
Brilliant. Thank you very much. And then we'll move on to David Ray. Could you, tell us the project that they've sent me, the River Clyde crossing, the information that they've sent again is just as mind-boggling. I mean, there's a massive cost, the depth. I mean, could you just tell us a little bit about that project too, please?
Yeah, sure. And it's interesting hearing David talking about 140 kilometres of pipeline when mine was 2 kilometres. But within that 2 kilometres, we had a huge amount of obstacles and technical challenges to overcome. As a bit of background, the Erskine Bridge crosses the River Clyde, and it's a 4-lane, 2-cycleways suspension bridge that, when it was built, was the longest bridge of its type in the world. It's a kilometre. The bridge is 1 kilometre long, and it's 45 metres above the water level, and it's got main bridge piers that are 38 metres higher than that. And there's 2 12-inch high-pressure gas pipelines, one on either side of the bridge, and they were built into the bridge as it was built in the late 60s, early 70s. And basically, these pipelines have been out in the open air since that. So they're as old as I am, these things. And so I know how much wear and tear I've had in that time, and I've not been out in the elements for the full period. So these pipelines were getting to the point where they needed some work done on them, and Transport Scotland, who were the organisation who own and maintain the bridge, they had a massive refurbishment plan to come for the bridge, which was a motivation for us to try and it gives a window of opportunity to try and remove these pipes as well, because the burden that SGN had in maintaining these pipes, because they weren't piggable, they were all A4, what we deem all A4 pipelines. They had to be visually inspected every 2 years, and that was a huge cost, because there was a gantry that ran below the bridge, two gantries, one either side, and we had to rent that gantry from Transport Scotland to physically go and inspect these pipelines every 2 years, and there's a huge kind of operational cost to the business in that. And so given that ongoing OPEX cost, together with the condition of the pipelines after their 50 years of use and exposure to the elements, SGN made the decision to make this investment, which was over £20 million, to replace these 2 pipelines with a single crossing below the Clyde. Now, it sounds easier than it was, because on one side of the Clyde, we had the A82, which is the main route to the West Highlands in Scotland. It's a dual carriageway road that's very, very busy. It's the main route, as I say, to the west coast. We had the route of the Antonine Wall, which is a World Heritage Site. We then had a railway line and station, and we had a church and church grounds. We then had the Forth and Clyde Canal at the location of a lock, which is also a World Heritage Site. And we then had the River Clyde itself, and on the other side of it we had Mar Hall, which is a 5-star golf resort, and beyond that we had a community woodland. So all these, and there was one location where we could cross the river, and that was it. Every other part had been developed, and there was this one very narrow corridor, which at the narrowest part was only 15 metres between one of the bridge piers and a house, and we had to thread the HDD through there. So we did a lot of work through feasibility studies. At one point we had HDDs that crossed underneath the span of the bridge, so they started on the east side of the bridge, crossed under the span and came up on the west side of the bridge, and we looked at that as an option. Then we looked at doing the whole job in one HDD, but the ground conditions varied so much towards the top and with the rail crossing, and we wouldn't be able to get like acceptable levels of settlement below the railway, so we had to change the HDD there. And there was a 48-inch pre-stressed concrete water main that took water across the Erskine Bridge as well, that we had to cross, and this was 50 years old and was quite fragile, so Scottish Water were a bit sensitive about what happened in the vicinity of that asset. So it was just constant challenges to get across. So we invested heavily in feasibility, doing boreholes in the middle of the river, boreholes along the route. We engaged some HDD specialists to guide us through the process, because I'm sure you can imagine that, as I say, a bridge that's 45 metres above the ground carries 4 lanes of traffic, etc. We had to do an HDD within 7 metres of the piled foundations, and to try and get Transport Scotland on board and get them to believe that what we were doing was not going to impact the bridge in any way, or the safety or stability of the bridge. To get consent to install our pipeline was as much of a challenge as actually doing the job turned out to be. But I had a fantastic team of engineers and specialists. With geotechnical engineers, civil engineers, with mechanical engineers, all feeding into the process of getting us through the logistics of getting consent to do it and then installing it, and it was very challenging. But a fantastic. As soon as I heard about the project, it was one I wanted to be on. And I did ask if I asked to get put on it. As a colleague of mine was originally on the project who was coming up for retirement, so I knew the job was coming up, and I did ask and said, look, I want to be on that job, can I have it? And thankfully I was given it. So I did regret that decision in the odd day during the project and think, why did I ask for this one? But no, in the end it all turned out well, and we did successfully deliver a new 18-inch pipeline, which was directionally drilled below the River Clyde, which was very, very challenging. That directional drill also went below the Forth and Clyde Canal lock and a local road, and up the driveway of the church, and emerged in the ground behind the church. We had to do a micro tunnel. We had a 20-metre deep shaft because the railway was in a cutting. The access shafts had to not only be the depth of the cutting, but the depth required below the railway as well. So we had 8-metre diameter shafts, 20 metres deep, to get access down to do the micro tunnel. We auger bored below the 48-inch pre-stressed concrete water main, and one of the things that wasn't originally flagged up as a huge challenge was the final stretch, which was to lay it up the public highway to connect into the existing site, and this was taken as across the A82. And being at the foot of the Kilpatrick Hills, the groundwater was confined and under pressure. So when you dug into the groundwater actually came out, pressurized and came up in the air above ground. So the structure would have been, if we had just pumped groundwater, we could have lost the structure because we'd have brought fines out and it would have caused collapse around the structure. So we had to bring in dewatering specialists and design a specialist dewatering system that would lower the groundwater to enable us to excavate below the 82 through an underpass without putting the structural integrity of the bridge at risk. So that was a very complicated little operation through a very restricted area that we weren't allowed to close because there was no other way of accessing it. So we had to maintain traffic flow at all times while putting an 18-inch heavy wall steel pipe through basically a single lane, welded in situ with very heavy ground retention structures with the dewatering pipes in there. So it was really, really congested little area. So that was just the kind of last hurdle that we had to cross.
Yeah, and it makes me think of all the stakeholder engagement that you both had to have done. Did you, and I'll chuck this over to David Butler in the first instance, did you imagine that you'd have to do so much when you first wanted to get into engineering? Did you think that all this stakeholder engagement would have been as prominent as it is now back then?
No, definitely. When I started out in engineering, it certainly wasn't part of any of the courses we did. We did a tiny thing on presentations, and that was it. Very, very basic presentations practice and so on like that. But what we found straight away once involved in a company like Phoenix and very much like ourselves, as engineers, you have to be able to get involved in the whole stakeholder element of it. The discussion with people. Jobs become much easier the better you're able to communicate with people and with the general public. So, and again, I suppose it's the advantage of being in a small company. There's nobody else there to do it. You have to be able to, so one day you're dealing with customers who have a problem with their driveway, and the next day you're dealing with the council, the next day you're dealing with a minister. So you're ranging it. You have a wide range of sort of people that you have to be able to be comfortable with and being able to speak with.
And then going into sort of you've obviously had to overcome a lot of obstacles and issues along the way. And it'd be very interesting to know, like, what innovation, because there's a lot that you've done, having to start from scratch and build all this stuff up. There's GIS, there's databases, there's CRM, there's so much to do, and it'd be interesting to sort of get a snapshot on some of the innovations that you've adopted.
Well, certainly when I was in Phoenix, one of the key things I was involved in directly was GIS. So I'm a big believer in GIS, and I'm a big believer that everybody who is in the field and people in the offices should have access to GIS, should know what it is and where it is that they're talking about. So when you're talking to a customer, you can visualize where they're at, as opposed to they're just in a line on a spreadsheet or a line in a database. So that's one element of it that was fundamental to how we set up. The second element of it was, so I suppose it was slightly unusual from within an SGN organization, where there is a department that just deals with GIS and there's another department which takes the maps that somebody else does. Because we were over here and there were some issues in terms of compatibility between the geographical system here and the geographical system in GB. So we ended up being a lot more independent as a company than possibly would have normally been the case. So it worked out okay, and it gave me an opportunity to influence that way. When it comes to then other sides of things, I also was heavily involved in asset management before coming in. So setting up how we were going to organize and manage the contracts was something that I'd had the experience, the horrible experience of you're asked to do a report, but you've no way of getting the data out, and it always comes out in the wrong formats. So all of that kind of thing, I had that experience, so I was able to get to try and plan. It hasn't worked in every single instance, but by and large, everything is linked. So a pipe is linked to a job is linked to the rationale that it was going to be done, it's linked to the mapping, it's linked to any complaints that come in. So they're all linked within various systems, and the systems have been designed to talk to each other. So we had the advantage of being asked or given the opportunity to set up our work and asset management system. And we plumbed for a system called Microsoft Dynamics, which is a CRM system, but it's a highly customizable. So we've done a lot of work, and then we had to have consultants to do some of it, but as a lot of it is in-house, that we're able to do our own work ourselves. And that's where our asset register is stored, and that then we're able to link through references back into our GIS. So all these things are all talk to each other, which is good. Some of it's dynamic links, some of it is a bit of a more manual process. But because of these links, we're able to when a customer connects, we can say, well, the pipe went live outside your house. There was a complaint this day. You phoned in on this day. You got your gas connection another day. So we've all that traceability. And instead of the call handler who has to deal with it, having to go with multiple different systems, they can type in the address and it'll give you the full history of the site and gives you a little map showing where the house is. You can have access then to a map showing where the pipes are. So all of that is all built into the one. So I see that as another element that I'm very pleased with. And I suppose the final thing is anybody setting up a project is addresses, customer addresses or property addresses, is making sure that those are fully linked in. There's nothing worse than trying to figure out where an address is if you don't know. So even though you're buying in a system and you're buying in the data is never going to be 100%. But if you just you're trying to mash an addresses just on postcodes and so on, it can never really be done. And I know it seems like a very small thing, but we're only going to be a small company with 40,000 customers whenever we're fully fledged. But knowing where all those 40,000 customers are makes the whole thing an awful lot easier. So if anybody is setting up a new thing on it, make sure you get the address matching right.
Yeah, it's a very very critical point, and it's something I learned my lesson with very early on too. But it's nice, isn't it, to be able to have a blank slate, having learned what you've learned, and be able to create that end-to-end function, that process. It's a nice experience, I suppose, now, but I know it can be a bit of a nightmare going through it and setting it all up. But it's a very valuable tool, so I can certainly testify to plug in that for sure. David Ray, there's going to be 1,000,001 different things that you probably encountered, and different things, new products and services and processes that you've had to adopt to complete that project. Again, it would be similar to have a snapshot of some of the things that you've perhaps had to employ that you've maybe not ever used before, maybe a new innovation or something like that.
Well, some of the technology that we were using was like adapted technology from, like, the HDD technology was originally pioneered for offshore oil well drilling, and it was adapted many years ago for horizontal directional drilling. That's kind of old established technology, but the manner in which we were employing it, it was operating at the very upper end of its capabilities, and the ground conditions that we encountered below the River Clyde, they were so variable that to try and get the tooling right, try and get the mud consistency correct, there was no unique solution, and we kept the Clyde Valley was basically cut by a glacier, and so you had there was a geological fault through the location where we were crossing, and so one half of the river you basically had solid rock, and there was a downthrow on the fault there. In the other half, you had a mixture of everything from very, very soft saturated silts to huge boulders, very, very hard boulders. And to drill through that was operating the HDD technology at the extreme end of its capabilities. And because we knew that the ground was so variable, we were fortunate in that our principal contractor, the Murphy Group, were in their subcontractor LMR Drilling, were in my mind one of the top drilling organisations and one of the few companies who had the capability to physically complete this work. And we went with I think it was, I could be wrong, but I think it was a 9 3/4 inch drill rod, which was a very robust, large drill rod, and we had a large drilling head on that because we knew we weren't going to get too many goes at this, and there was no other routes. And if this failed, then basically all the investment SGN had made in this, which at that point was several £1,000,000, would have been written off with no product at the end of it. So we always had that risk that if this doesn't succeed, we're going to have to go back and say we've failed, we've spent several £1,000,000, we've achieved nothing, I'm sorry. So that was always in the back of your mind, that you had that risk behind you. So the we were drilling from the soft side to the hard side, and trying to steer the drill in these very, very soft silts, because you rely on your HDD cutting head basically biting into the ground to kick off and steer, whether it's left, right, up or down, and it just wouldn't bite in to anything. The ground was too soft, and so on a couple of occasions the drill would go offline, either deep or to the right, and so we had to basically fill the drill void that we created, grout it up with grout, and pull the drill back, and then try and use what we grouted up as something to bite into to steer, to kick the drill back on line. But every time you were doing that, you were going through these soft silts, your hole was opening up, and to get the cuttings out, you were having to increase pressure, so that was increasing the risk of losing your fluid through hydraulic ground fracture. And so we had all these different variables to weigh up, and we had all the different specialists who I consulted for advice. The contractor was telling you certain things. We had the drilling advisors that were telling us certain things, and a decision had to be made of, is this going to be a success or not? Do we, and you had to use your judgment as an engineer to take all the advice you're given by by many different specialists to say, what's my gut feeling on this? Are we wasting the company's money? Is this ultimately going to fail, or do I think that we can get this through? And I had two advisors, one who was an optimist and one who was a pessimist by nature. And so one guy was saying, we're doomed, Captain Mannering, and the other one was going, nah, don't worry, it'll be all right. And so I had to take the technical details of what both of them were saying and try and make a decision on whether we had a chance of achieving this. And so ultimately, the pipe's through now. So, I was always of the opinion that, yes, this is getting very close to the limit, but I still believe it can be done, and I had confidence in it. And we had this kind of, once we reach the rock, we'll be all right. And it was that, if only we can get to the rock. And then we got to the rock and it all went horribly wrong again. So everybody was saying, right, well, you got to the rock now and it's failed again. So are you going to give up? Are you going to? And there's like, no, let's go back. Let's think about this. Let's, we'll there are other options. How much will the options cost? So I mean, every, as well as the technical challenges of it, you had people going, well, how much is this going to cost? And you had to work out the commercial impacts, and so every other day it felt like you were doing a new budget and you were submitting this up and updating your risk registers, and and it was just constant. At the time, you were just getting on with it as your daily job, but you look back and you think that was fairly intense. And
you've highlighted a point about skills there, the skill sets that an engineer requires. You're doing finances one day, you're having to make judgment calls on the day based on the information that you get back. I mean, what sort of skill set? I mean, if you could sum it up as some of the key, let's say 3, 4, 5 key strengths an engineer should have in today's engineering world, what would you say they are?
Well, you need a calm, rational head. You can't afford to be a hothead. You can't afford to be too reactionary. You've got to consider all the information that's available and very quickly discount the stuff that is not relevant. You've got to be able to cut to the chase and pull out all the bits that are key to whether something's going to happen or not, and analyze them. Use your critical analytical skills to take the relevant information from the things that are presented to you and make a decision, or present a decision to someone else, or present a recommendation to somebody. So for me, it's been able to separate the wheat from the chaff and cut to the chase is one of the key non-technical skills, if you like, that an engineer needs.
It's interesting. And David Butler, it'd be interesting to get your take on that. What you think engineers of today, what some of their key critical skills engineers of today require?
I think David's hit it the nail on the head with that one, in terms of being remaining calm, and being able to provide a rational decision, or make a rational decision once you get in the information. I think at various different levels we're all faced with real challenges as engineers, and a lot of it is more to do, you have the technical problem, yes, but how do you deal with the people around the technical problem? It's sort of people management skills. So if you don't have the people management skills, ultimately it becomes a bigger technical problem, and something that can be managed becomes unmanageable. So you really need to have those people skills of being able to not necessarily just get on with people, but also be able to influence, but at this, without becoming irrational about it.
And do you think that will still be the same? You still need that skill set in, say, 5 or 10 years, or if the network transitions over to hydrogen, do you think that will still be the key skill, or do you think that's going to move to something else?
No, I think definitely that's still going to be, we're still going to have a lot of technical problems. Certainly we're hoping that the network that we're building over here, which is pretty much an all PE network, that hydrogen is going to be the future within that network. But there's still the other skills that are needed in terms of the downstream engineers, the changes to upstream in terms of pressure regulation and so on that we'll need, and to ensuring that people coming through. That's going to actually be probably the biggest challenge, I think, is making sure that we get enough of the right skilled people coming through, because even as it is finding the right people who can lay gas pipes or install gas pipes is becoming harder and harder to find people who want that as a lifestyle. It's not easy. Now, I think I already described, and I imagine Glasgow is not that different in terms of weather. We had shocking weather for months and months on end. It takes a special kind of person who's going to want to go out and be in that rain and that terrible weather. So it's making sure that we're able to harness those people in the right way. So I think the same skill sets that we're showing now will also be required later on as we transition.
And then talking about the engineering, the skill sets required around engineering and the technical discipline itself, there are going to be some, well, we know there are going to be more than just some challenges. But if you could sum that up, and maybe a few key challenges that you perceive for your network, what would they be?
I think probably one key challenge that we're going to have is how will the network be configured? So it's more of a dynamic configuration of a network with maybe multiple sources coming in from different directions, So is it a case that the hydrogen will come from a single source as we currently have? So you have a transmission system which then feeds out, or are we going to have more sort of discrete networks fed in the opposite direction, so you're almost fed back in from the smaller side. So that's going to be a challenge, and it is one thing that would concern me, that in terms of I'm building a brand new network, but I don't know what the size, I'm building it in the traditional style. You've got your feeder main and the infill mains off the side, but it could turn out that some of those infills are undersized on the basis that the gas is going to come like a different direction. So I think that's going to be a big element. Another big element is the level of disruption to the general public. And when I say just the general public, I mean all of us as well. And like, we're all going to have to make these changes. And the impact on properties and the customer experience, our view certainly at this stage is that the transition to hydrogen would be the least disruptive for the general public, as opposed to having to change their house for heat pumps or whatever. So we see that as being a big thing.
Yeah, it's interesting. It's something that I've been thinking quite a lot about around pipeline diameters and pressures and flow rates and all sorts, especially downstream with some of the appliances. It's one that I've been sort of scratching my head over, especially over the last few weeks, actually, looking at how that could be a reality. But we'll have to wait and see, because I think there's a lot of work going on around all these like high deploy and H21 and all this other stuff that's going on that should be able to prove that sooner rather than later. So I'm very much looking forward to that for downstream. David Ray, it'd be interesting to get your take on it. What your take is on the future requirements for engineering, and where you see some of the biggest challenges over the next few years or so.
For me, the biggest challenge is on skills. And if the hydrogen network is, if we are going to try and achieve the amount of pipe in the ground from a transmission point of view, that certainly the targets are, and the relative companies are looking to achieve, is trying to find the skilled people from both clients and contractors to get that pipe in the ground. Because it doesn't seem to me that long ago that we were building big pipelines every year in the UK, but when you look back, it is actually quite a few years since we've built any big pipelines, and a lot of the be it the welders, bending engineers, and just general skilled labour and management, just project managers, project engineers, construction managers, because we haven't been building pipelines, a lot of these guys have either gone abroad or retired or just gone into other industries. And to try and get that skill set back to achieve the ambitious plans that we have in the UK to get the hydrogen network up off the ground, for me, is a massive challenge.
One of the things, just on that note as well, it's made me think a lot more about sustainability. When we're talking about skills and things like that, it's the awareness of sustainability. I remember back in the day, I'd turn up on site with a great big thumping diesel generator. I'd have all the knowledge in the world to get the job done, on time, on budget, but all the kit that I'd bring in too is very old. And of course, as we transition now into a more sustainable future, there's that whole I feel that there's this sort of move towards also understanding new kit, new technology.
Mm-hmm.
I mean, there's these hydrogen powered backup fuel cells now. There's these lithium ion battery banks that you can bring on site to power your plant and equipment. There's all sorts of stuff going on too, but it's a very different way, in my opinion, of working, and that interaction, it will be very different too. Did you, just out of my own interest and curiosity, did you employ any sort of novel solutions like that on site to power your plant and equipment?
Yes, I mean, one of our where we had to do the microtunnel and we were launching the microtunnel, it was we had to take over the local village football pitch and park, and it was right beside some large houses that overlooked it. And so the traditional big thumping diesel generator that you mentioned to power the cabins overnight to keep your security guard warm and power his TV and stuff like that, but wasn't really an option, and there was no mains power available for it. So Murphy, the principal contractor, they brought in it was a solar powered lithium ion battery backup thing that during the night it ran on the batteries. During the day the batteries were charged up from the solar panels. If there was an issue with the lack of sun or whatever, it had a diesel generator there to power cabins during the day when noise was less of an issue, and also to make sure your batteries were fully charged for the night time when noise was an issue. So, come 5, 6 o'clock, 7 o'clock, whenever the site closed, it went silent. So they didn't have that kind of hum of a generator off in the background. So that, and we also used like noise deflectors on the fencing at Mar Hall when we were where the exit point for the HDD, because a 5-star golf resort and they didn't want their golfers being put off their tee shot or their putt when with the noise in the background. So we had some noise barriers on the fence in there to minimise the noise disturbance to the golf course as well.
I can imagine it's a similar thing that you've encountered or dealt with, David Butler, with the work that you've been doing building the network over there. Have you employed these sort of low carbon technologies when you're in this sort of construction phase?
I would say no. To be honest, we haven't. So I suppose from a noise point of view, we've generally been very much in the countryside. So it's been, so we have been out, and so far there hasn't been that driver. And I think one of the problems was going to be in that in order to innovate for these different ideas and coming in, they're not cheap as ideas, and a contractor is either going to have to incorporate that somehow into their price, but then that can potentially make them less competitive, or the regulatory framework in general would need to be moving in a direction that would permit clients like ourselves to be able to go for a project like that, or to bring in these type of innovations. The current climate doesn't really permit that kind of innovation, which is probably quite unfortunate. You know, it would be very useful.
I think that will change. I've certainly seen it in some of the T2 documentation that Ofgem has made allowances for carbon offsetting and things like that. So that should ease the adoption of this sort of technology. So there's still a chance with your submission, maybe potentially.
Well, I think probably the biggest saving that we make in general within our business and across over here is through extensive use of directional drilling. So we do a lot of horizontal directional drilling for all the mains. So generally, and even on the IP that we put in, about 66% went in, but 2/3 of it went in through directional drilling rather than traditional open cut. So we were able to save in terms of what had to be taken to landfill and spoil and so on. So there's huge savings in that regard. And we would see savings then from coming into the distribution. So we've installed about 250 kilometers of distribution so far on the project. And again, the majority of that is put in through directional drilling. So we are able to sort of bring those savings in terms of spoil, etc.
That's a good, waste is one of the biggest things. I mean, spoil and waste, it's one of the things that I'm looking at the moment for construction and trying to recover and reuse is another one of the things that we're spending quite a lot of time and effort with. It's a very important space. I'm going to pick up a question from Chris in chat just before we move over to close, and it's to David Butler. Chris asks if you created a virtual showroom or showrooms to give customers a choice.
Yeah, so I'm sort of embarrassed for him to remind me of this. Yeah, so one of the things that we've done, it didn't really so much come around from a sustainability point of view, but one of the things that we've done over the COVID issue is we weren't obviously able to go and meet customers face to face. So we developed our own sort of basically a virtual studio where customers can come onto our website, book an appointment with one of our sales advisors, and are able to carry out that sales discussion directly. The sales advisor is able to get the customer to show them where they think the meter would go, and so on. So they're able to do all that kind of surveying remotely. So that's been quite successful. We haven't moved at this stage to like a full showroom showing off different appliances or anything like that, but that's certainly something that maybe in the future.
Yeah, it's a pretty innovative way of dealing with the pandemic. So no, it's definitely worth acknowledging that. Right. So in closing, I think it's just in time. I'd like to thank you both, David Butler and David Ray, for joining us today. And my final thanks has to go to IGEM and EUA for the promotion and delivery of today's webinar, and to everybody that joined us. If you want to find out about the forthcoming Gas Industry Awards webinars, then please visit igem.org.uk. So thank you all and have a pleasant afternoon.
Thank you, Ben.
Thank you very much, Ben. That was excellent.
Thank you both.
Yeah, it's a pleasure. Bye.